For 43 days, NASA remained silent. A government shutdown prevented any official statement about the mysterious object discovered in July. In this information vacuum, online speculation exploded. Alien spacecraft, artificial object. Last week, NASA broke its silence. The truth is indeed of natural origin, but no less spectacular. The interstellar comet 3I Atlas is erupting with ice volcanoes. And what we're learning is rewriting our understanding of worlds beyond our solar system. On December 1, 2024, a research team led by Josep M. Trigo Rodriguez from the Institute of Space Sciences in Catalonia published their analysis. 3I Atlas displays spiral-shaped jets, fountains of frozen material shooting from its surface into space. These aren't ordinary cometary jets. Observations from the Joan Arrow telescope at the Montsec Observatory reveal a pattern that researchers interpret as cryovolcanism. Volcanic eruptions where instead of lava, frozen water, carbon dioxide, and other volatile substances burst forth. This is the first direct evidence of cryovolcanism on an interstellar object. We're literally watching in real time how a body from an alien solar system reacts when our sun warms it. NASA coordinated the most comprehensive observation campaign in the history of interstellar object research. 12 different spacecraft, from the Martian surface to the James Webb Space Telescope, turned their instruments toward this cosmic wanderer. The Mars Reconnaissance Orbiter photographed 3I Atlas from just 30 million kilometers away, the closest images we've ever captured of an interstellar object. The Perseverance rover paused its rock analyses in Jezero crater to take photographs. Even MAVEN, designed to study Mars's atmosphere, captured the ultraviolet signature of hydrogen atoms surrounding the comet. The Hubble telescope provided size estimates between 440 meters and 5.6 kilometers in diameter. Webb analyzed the chemical composition with its near-infrared spectrograph, and the Stereo mission observed the comet as it passed behind the Sun. A region Earth-based telescope cannot capture. This coordinated effort was only possible because 3I Atlas's trajectory carried it through our inner solar system. On October 30th, it passed its closest point to the Sun at approximately 210 million kilometers, just outside Mars' orbit. That's when the ice volcanoes became most active. The analysis of these jets reveals a surprising composition. Earlier observations already showed unusually high concentrations of carbon dioxide, far more than we see in typical comets from our solar system. Researchers now suspect that this is not the case. 3I Atlas is structured similarly to trans-Neptunian objects, dwarf planets and bodies orbiting our Sun beyond Neptune. If they're correct, we are getting our first glimpse into the composition of icy bodies in other solar systems. It would mean the processes that shaped our outer solar system might be universal. David Jewett from UCLA, a veteran of comet research, describes a particularly fascinating aspect. 3I Atlas shows what's called an anti-tail dust particles moving toward the Sun rather than away from it. These particles are unusual. They're unusually large, about 100 micrometers, 100 times larger than typical comet dust. They are influenced so slowly by the Sun's radiation pressure that they're currently still drifting toward our star. This suggests a surface that is literally rupturing under heating. Explosive outbursts rather than gentle sublimation. And this tells us something profound about how volatile-rich bodies behave when they encounter stellar radiation after perhaps billions of years in the cold of interstellar space. Now about those online speculations. during the shutdown in the absence of official information. Some suggested this might be an artificial object echoing the 2017 Oumuamua controversy. On November 28th, after the shutdown ended, NASA made clear all observations confirm 3I Atlas natural origin. The coma, the gas and dust cloud around the nucleus, the behavior during solar approach, the spectroscopic signatures, everything corresponds to a comet. An extraordinary comet without question, but a natural cosmic body. Science lives on evidence, not speculation. 3I Chalice has already passed its perihelion and is now accelerating back out into interstellar darkness. Its hyperbolic orbit means it will leave our solar system and never return, but we still have opportunities. On December 19th, 3I Chalice reaches its closest approach to Earth at about 270 million kilometers. For professional observatories worldwide, that means more observation time. Astronomers are particularly interested in seeing whether the ratio between carbon dioxide and water without gassing changes now that the comet is moving away from the Sun. JWST expects water production to become stronger, which would provide further insights into the structure of this interstellar wanderer. 3I Atlas is more than just a comet. It's an ambassador from a world we'll never see, orbiting a star we may never identify. Billions of years old, formed in the earliest days of an alien solar system. The ice volcanoes we're observing now tell us that even in the cold between stars, geological processes, or rather cryological processes, are at work. Activity exists in forms we're only beginning to understand. In an era where we search for Earth-like planets and contemplate the possibility of life in the universe, 3I Atlas reminds us that the universe is full of surprises, and sometimes those surprises come directly to us.